Okay, we're gonna get started, guys. Welcome to our first official class here. Again, the Friday sessions are for those of you who are in quarantine or who miss class for another reason. This is kind of like the makeup class from Monday and Wednesday's material. So the first week, we're gonna cover chapters 1 and 2 of your textbook. And the first chapter is covering a lot of vocabulary. And so you really need to take time on your own to go through that vocabulary and make sure you feel comfortable with it, okay? And then the second chapter is about chemistry. So if you feel comfortable with chemistry and those topics, then you can move through the material pretty quickly. But if you are the person who doesn't feel comfortable with chemistry, please make sure you look at the videos that I made and you read the chapter really well and you pay attention to that material. So with that, I'm going to share my screen here. Okay, so if you are on your Canvas shell here, let's pull this up. As always, if you guys have questions, please unmute yourself and ask or put them in the chat. So this is, again, your Canvas shell. You have your to-do list on the right-hand side. So you've got some things coming up this week. You've got another guided reading question, or GRQ, for chapter 3. You've got questions and clarifications, so things that didn't make sense about that reading, you can put it here. And then next Wednesday, you have due a discussion post, and I ask that you also comment on someone's post. So I know it seems silly, but it just, it makes sure that you've read through what other people are saying and see if you guys are all on the same page, okay? So we're here in Module 1. These are the things you guys did before this class, which is great. This is what we're going to do in class today. Again, next week we'll cover cells and we'll move forward with that. You've got a homework and a quiz as well. So if we are here in our Class 1 agenda, this is what the page looks like. If you guys can open up your Class 1 attendance quiz, and I want you to tell me the 4 types of macromolecules. You're going to take the quiz, and I want you to tell me the 4 major types of macromolecules, please. 4 major types of macromolecules. If you could tell me the 4 types of macromolecules. Okay. Okay, so while you guys finish that, I'm gonna answer some questions that I had gotten about this material. Okay, so we have 4 major types of macromolecules. We're gonna get to them in a minute. I just wanna see if you remember from your reading. So while you think about that, I'm gonna pull up a PowerPoint here that I put together. And again, I've shared this so that you have access to it on that Class 1 agenda page. And again, if at any point you have questions, you can put them in the chat if you don't want to unmute yourself, or you can unmute yourself and ask. Okay. So again, chapters 1 and 2 are kind of our foundation here, the basics. So we're going to start with the definitions of anatomy and physiology. So anatomy is the structure of our body, and it can either be gross anatomy, which is just like what you can see with the naked eye, or microscopic anatomy, which you need to use a microscope to see. So it's the shape of things. Whereas physiology is the function, what it does. And this is a big theme that we're going to come back to over and over and over again. Structure relates to function. The shape of things determines what it can do, okay? At a anatomy level, when we think about muscles, and we'll get to this when we do our muscle chapter, you have these thin pieces of cytoskeleton in your muscles that look like little strings. And your muscle is able to contract. It's able to do the function of contraction because those thin filaments are so small, they can just kind of slide past each other. If they were big globular proteins and they took up all this space, you wouldn't be able to do that. They wouldn't be able to have that job, right? So the shape allows it to do its job. And we can think about that in a non-biology sense, like a wheel. A wheel is round, and that allows it to roll. If a wheel was square, it wouldn't be able to roll. Okay? Structure relates to function. Anatomical position. So this is the standard body position. So when you're standing upright, and the key for this is that your palms are facing forward. Now, if any of you guys do yoga, this is like mountain pose, right? So you're standing, your feet are parallel, your arms are at your side, your palms face forward, and your thumbs point out. And anatomical position is important because it's the universal reference point. So it is how we all discuss the body, especially in a healthcare setting. We want to make sure that we're talking about the same thing, especially when we use directional terms. So we want to establish that reference. And if you're working in medicine or in a healthcare field, anatomical position is from the patient's perspective. For macro, yes. Morgan wanted to clarify the attendance question. Yes, so the attendance quiz question, 4 major types of macromolecules, that is the question. Yes. Okay. So again, the anatomical position is the major reference point. And if you're working in a healthcare setting, it's from the patient's perspective. Okay. The other major theme of anatomy and physiology, so it's structure and function, and the other major theme is homeostasis, which are our set points in our body. So your body is kept in a delicate balance. You don't want things to go too much in either direction. Anything from temperature, right? If you get too hot, you start running a fever. If you're too cold, you can get hypothermic. To blood sugar, you don't want that to be too high or too low. And so your body keeps those values at this perfectly balanced set point through this homeostatic control network. And this will make more sense when we start to talk about the systems of the body and we give actual examples for each of these things. But in general, you have a stimulus that will change this variable that will be detected by your receptor, which will send information to your control center, which will say something is out of whack here, and that will send information to your effector, which will bring the value back to normal. So if we think about breakfast, a lot of people told me that their favorite breakfast food was chocolate chip pancakes or waffles, which are excellent choices, but those are very sugary breakfast choices. And so when you eat chocolate chip pancakes, your blood sugar is going to rise, and that's going to be detected by your pancreas, and your pancreas has receptors in it which will detect that high blood sugar and will then say we should release insulin, and insulin will go to the cells of your body, and the cells of your body will then take up that glucose and it will bring your blood sugar back down. And traditionally, most of the homeostatic control networks in your body use something called negative feedback, which is where the product of the reaction decreases that reaction, so it turns it off. So if we think of this homeostatic control network, the response will then be turned off. So you release insulin, your blood sugar falls, and then your pancreas stops releasing insulin. If that wasn't the case, if you kept releasing insulin, your blood sugar would start to fall, right? And you become hypoglycemic, which is also bad, okay? So most of the systems in your body use negative feedback. A few of them use positive feedback. This is more rare in biology, and this is where the product of the reaction will increase that reaction. The classic example of positive feedback is childbirth. Now, this is not a joy I have yet to experience for myself, but word on the street is when you have a contraction, it doesn't just stop, right? It's not like one contraction and there comes the baby. Instead, you have a contraction and they get stronger and stronger and closer together. That one contraction signals the cycle to keep going and going and going. Positive feedback. Okay. Anatomy terms you need to know. So most of you have your video off, which is totally fine. Totally allowed to do that. But we're gonna play a little Simon Says, and I'm gonna assume that you're doing it. Okay. So good morning. I would like you to point in the superior direction for me, please. Point superior, point inferior, great. Point ventral, which is towards the front of your body. Point dorsal. The way you can remember dorsal, has anyone watched Shark Week? If you're a fan of Shark Week, they got a dorsal fin. So dorsal's on the back. We can also use the words anterior or posterior. Posterior, I always think of like butts. Posterior side, again, the back side. So point superior, inferior, ventral, and dorsal. Okay, let's talk a few more words. Medial is to the middle and lateral is to the edge. The classic example of this is going to be on our hands. Why? Because our hands are in anatomical position. Our thumbs are going to face out. So your thumbs are always going to be on the lateral side and your pinkies are always going to be on the medial side. So we have lateral and medial. Okay, now when we get to limbs, we can't use superior and inferior. Why? If our hand is down at our side, then the most superior part is going to be the shoulder. However, if we raise our hands, now all of a sudden the shoulder is inferior. It's pointing down. So instead we use the words proximal and distal. Proximal is going to mean closer to the side of attachment, so close to the body, and distal is going to mean further away. So our shoulder is going to be proximal, our hand is going to be distal. So I want you to point medial, point lateral, point to your proximal part of your arm, and your distal point of your arm. Great. Superficial and deep, you can't really point very well. Superficial is towards the surface, it's like your skin. Deep is internal. Okay, take a deep breath in. Let it out slowly. You have to know these words. I apologize in advance. There are a lot of them. You need to know all of these vocab words. Some of them are more intuitive than others. So if you understand that your deltoid muscle is here on the curve of your shoulder, then you're going to know that that's your deltoid region. Some of them are named after the muscle, right? Your gluteal region, for example. Others are named after the bone. Your scapular region is after your scapula. The occipital region is your occipital bone, right? The femoral region is your femur. So some of them are a little bit more intuitive. Others are you just have to study. Okay, so this is where you got to make flashcards, you got to make a Quizlet, you got to draw pictures, right? You got to get familiar with these terms, okay? We're going to switch gears now and go to chapter 2. So again, chapter 1, that's our vocab chapter. This is a chapter where you really need to make flashcards. Please don't wait until the day before the exam to start making those flashcards or that Quizlet, because at that point you're just like gonna have to cram information in and it's not gonna be effective. So start today, start this weekend, start working with those words, okay? And see if you can get them kind of under your belt here a little bit. Okay. Let's talk about when will our first test be? Okay, I don't remember the exact date off the top of my head. It is in your syllabus. In your syllabus, you have your first test. Your test is in person, so it's on Monday or Wednesday. There's no virtual test, so you have to show up in person based on your last name, okay? Based on your last name. It's in your syllabus. Mia, I will look at that when we finish this little short lecture. Okay, so chapter 1 is vocab, chapter 2 is chemistry. So again, if you feel really comfortable with chemistry, you can move through this material quickly. If you feel less comfortable, please look at all those videos that I made on my YouTube channel that I've linked on Canvas, and spend some more time with this material. A few questions I got about chemistry. What are isotopes? So isotopes are atoms that vary in the number of neutrons. We want to remember that in our nucleus, we have protons and neutrons, and the protons, the number of protons, give us our atomic number. So carbon has 6 protons. That is defining. That's what makes it carbon. It's carbon because it has 6 protons. The neutron number can vary. So carbon can have 12 or 13 or 14 total atomic mass, bringing it from 6, 7, or 8 neutrons. And if the number of neutrons are unstable, so if it has like way too many neutrons and it can't hold all of them in its nucleus, it will start to decompose and it will shoot off those neutrons. And that is what we call radioactivity. So that shooting off of neutrons leads to radioactivity. And scientists and medical professionals have taken advantage of this radioactivity because you can actually detect it. I'm not going to get into the engineering behind detecting radioactivity, but this is what PET scans do. So they use a tagged biomolecule that has a radioisotope. It has this unstable nucleus, and it's going to shoot off neutrons, and you can pick that up with a machine. So that's how PET scans and other radioisotopes work. Okay. So a quick question about organic versus inorganic. Organic just means carbon-based. I make this joke in the grocery store. My husband does not find me funny. Organic just means it has a carbon-hydrogen bond in it. So things like glucose, proteins, lipids, those are all organic molecules. You study them in organic chemistry. Inorganic are non-carbon-based molecules, usually small things, salts, waters, etc. Let's talk about bonds. So we talked about the nucleus, how we can have isotopes, right? Around our nucleus, remind ourselves, around our nucleus, we have an electron cloud. And when 2 atoms come near each other, what interacts is their electron cloud. And that can react If they're stable, nothing's going to happen, right? They have a complete valence shell. This is all review, right? A complete valence shell, so they're not going to bond. However, if their valence shell is incomplete, they're going to seek to bond. Now, if they share their electrons, that's a covalent bond. The sharing is caring model. And there are two ways that they could do that. In a nonpolar bond, they've shared them equally. They create a uniform shape. So there's no greedy people. However, sometimes some of the atoms get greedy, usually the big ones. Like look how big oxygen is compared to hydrogen. And so oxygen is going to pull a lot of those electrons away from the hydrogen, and this creates a polar covalent bond. So the electrons are shared, covalent bonding, but they're polar. They're distributed unequally, leading to a partial negative charge and a partial positive charge. Okay. So those were the questions that I had gotten ahead of time. Those are the questions that I had gotten ahead of time. We're going to switch gears here and we're going to do an activity. So if we go back to our class 1 agenda, Mia, let me look up for that date for you while I have you on. So we go through module 1 in the next 2 weeks, and we do module 2. We have 2 classes on that. March 8th and March 10th is your midterm. Okay. Group A, March 8th, Group B, March 10th. Okay. So we're here in our class 1 agenda. We're here in our class 1 agenda, okay? And the thing that I want you guys to work on is this worksheet. So it is the language of anatomy worksheet. And we're not going to do the whole thing, though I recommend that you use the whole thing as a study tool, okay? I'm not going to be grading the whole thing. We're only going to be grading 2 sections from it. So do you have to, yes, you do. Do you have to submit anything? Yes, you do have to submit something. I'm about to tell you what we're about to work on. So I would like you guys to work on for the next few minutes here, for the next until 9:35. I'm going to put you guys into breakout rooms to talk about this worksheet. I want you to work on section 2 using these directional terms for this. So you're going to tell me the thumb is blank to the ring finger. Now, you can download this document and type it. You can handwrite it, but you need to be working on a document for part 2. And then for part 3, this is kind of hard to do because you have to draw a picture. I recommend you do it to study, but I want you to work on this question, part 3, question 2. So give me these words. So again, we are working on part 2, directional terms, and part 3, question 2, words, okay? And what I'm going to do is I'm going to put you guys into breakout rooms to talk about this work, okay? And you're going to have to submit your individual assignment. So I'm going to put you guys into 2 breakout rooms. Feel free to talk with the person who's in the room about what you're putting down for your answers, so you guys like come to some sort of consensus and agreement, and you're going to have until 9:35. Okay, are there any questions before I open up the breakout rooms? No, okay. No. I am gonna randomly pop into them to make sure that you guys are actually doing your work. So you're gonna get into the room, you're gonna turn your microphone on, you're gonna talk about the answers. Okay. So I've opened up those rooms. Please go and join your breakout room. Awesome. Heidi. Okay, there we go.
Of anatomy worksheet. If you go on Canvas, it's under the class 1 agenda.
Thank you. How's it going, guys?
Good. We were just confused, like on the name of the document that we had to work on.
Yeah. So in the class 1 agenda, there's an anatomy worksheet. Yes. Any other questions you guys have?
I think that's it for right now, for me at least.
Okay. Mia and Morgan, you guys doing okay?
Yes.
Okay, Morgan,
Yes,
how you feeling?
And actually, it's Maya.
I'm feeling a little better.
Morgan, you're feeling a little bit better?
Yeah.
Okay. Well, you guys get to work on that. At 9:35, we're going to come back as a class and talk about it, okay?
Thank you.
Okay.
I hope that was helpful for you guys. We're going to quickly go through the answers to that first section, and then we're going to do one last activity, and then we'll be done for the day. Okay, so let me just share my screen here. Okay, give me 1 second. Got a lot of tabs open. Make sure I'm in the right spot. Okay, so again, this worksheet is designed to give you guys practice with these concepts. Okay, so we didn't do all of the worksheet today in class. It would behoove you to make sure you're able to complete all of the worksheets, say before the first test. And it's a good way to test yourself, right? Especially with some of the other sections. Really, you're not able to tell if you know something until you quiz yourself on it. So let's talk about directional terms. So again, anatomical position, the thumb is lateral to our ring finger. Our ears are lateral to our eyes, which means towards the outside of the body. The abdomen, this requires you to know what the thorax is, right? Our thoracic region. So the abdomen is inferior to the thorax. Our skin is superficial to our muscles. Now we're talking on our limbs. So remember, with limbs, we use the words proximal and distal. So the shoulder is proximal to the elbow, and the hand is distal to the elbow. Are there any questions about that first section? Okay. So then what I had you guys do, we didn't do this section. So again, this would be good practice for you when you're studying, seeing if you can actually draw on a human. So you can print this out on your own time and work on this. Let's talk about these words. So cheek, buccal, the back of the knee, the popliteal region, armpit, axillary. The back of our head is occipital. Our breastbone is sternal. The front of the hand, so you can either say the whole hand is the manus region. The older version of the textbook also tells you that the front of the hand is palmar. But for this, your new version of the book, we would just say your hands, the manus region. Your elbow, acromial. Your butt is gluteal. Your fingers, those are digital, right? And your chest is thoracic. Okay. Any questions about that section? No. Okay. Well,
Miss Courtney, what did you say you had put for the back of the head? I had misunderstood you there.
occipital.
Occipital. Okay, I was just making sure.
Yeah, OCCIPITAL, I think, occipital. Mm-hmm. Good clarifying question. Any other questions you guys had about these ones?
And I'm sorry, the last one for your elbow.
Your elbow, ocranial, OLECRANAL, something like that. I'm a really bad spell.
Okay, yeah.
Any other questions you guys had?
And one last thing, with the two things we did, do you want us to copy and paste them and put them in another Word document and submit them to you?
I'll tell you at the end of class, I'll tell you what to submit and when. Yes.
Okay, thank you.
1 second, yes. Any other questions about the words? Okay. Okay, what I'm going to do now is I'm going to switch gears. We're going to briefly review our macromolecules, and then we're going to do one last activity. So let me pull up a whiteboard here. Okay, so let's briefly review our macromolecules. So this was our attendance quiz, right? So we have 4 major types of macromolecules. They are carbohydrates, and then you've got proteins, and you've got nucleic acids, and then I'm going to put all the way down here, I'm going to put lipids. And in your guided reading question, I had asked you guys to fill out that chart about your macromolecules. And I had asked you to put in information like the monomer and polymer, if I could spell, no, there we go, I can do it, polymer, and the function. I'm going to abbreviate function with FX, that's a common abbreviation, okay? So we had asked you to fill out this chart. So this is things that you need to be aware of. You also need to be aware of, and this wasn't in your homework, but it is in the book, so you vaguely need to be aware of shape. So you need to be aware of shape. And what I mean by that is you need to be able, if you're looking at a picture of something, be able to tell me, oh, that's a carbohydrate, oh, that's a protein, oh, that's a nucleic acid, that's a lipid. You do not have to be able to draw them yourself. So I'm not expecting anyone to be able to draw these chemical structures. That is it for a chemistry class, but I am expecting that you can recognize those shapes. Okay, so let's do carbohydrates together and just briefly make sure we're on the same page. Carbohydrates are the easiest because the words all start with either mono or poly. So the monomer, the building block of our carbohydrates, are our monosaccharides, right? Those are our simple sugars. Monosaccharides are simple sugars, our sucrose, our glucose. And those are usually depicted, they're easy to tell because they're in a ring structure. So they're gonna be a single ring, they have an oxygen in it. And the way I remember what the shape looks like is for monosaccharides, Fruit Loops. Fruit Loops are rings. They're very sugary. One Fruit Loop is one monosaccharide, and then a chain of Fruit Loops, our polymer, is going to be a polysaccharide. Okay, a chain is going to be a polysaccharide. And the function of sugar, the functions of carbohydrates in general, these give us energy. So that's why we need them. Your brain specifically can only take straight glucose. So that's why if your blood sugar starts to get low, you start to get hypoglycemic, one of the first signs that that's happening is you're going to get like a little lightheaded, a little foggy. It's going to be hard to pay attention, right? That's when you need some simple sugars. You got to drink some juice or something because your brain requires glucose. The rest of your body can break down protein, can break down fat, can do these other pathways, but not your brain. Okay. So again, the monomer is a monosaccharide, the polymer is a polysaccharide. The function is energy. For proteins, the monomer here is going to be an amino acid. An amino acid, that's the building block. The name comes from the two parts of the molecule. It's got an amine group and a carboxylic acid group, so it's an amino acid. And the polymer is going to be a polypeptide or a peptide chain, right? A chain of amino acids. And proteins have kind of the hardest function to define, right? Carbohydrates, energy, nucleic acids, we'll get to them. They're the genetic material, right? But proteins, they do a lot of stuff. So I'm just going to write do work. They do the work of the cell, right? They help form channels, they form enzymes, they form receptors, they form structural units. They do a whole bunch of stuff. They do the work of the cell. The last one that we can easily break into these categories are our nucleic acids. So their monomer are nucleotides, which are our A's, T's, G's, and C's for DNA, and our A's, U's, G's, and C's for RNA. The polymer, we call them an oligonucleotide, oligo meaning multiple, lots of things, oligonucleotide. And the function for our nucleic acids, these are our genetic material, right? DNA holds our genetic code. RNA is the messenger that helps transport out of the nucleus, and then it is the instructions to make proteins. So nucleic acids are our genetic material. Okay, I put lipids all the way down here by themselves because lipids cannot easily be broken down into this monomer polymer thing, right? And so you can't really say what the monomer is or the polymer is. And lipids also have a diverse array of functions. They form membranes. They also provide energy. And so it's harder to do this thing with lipids, but they are still a class of macromolecules. Okay. So I hope that was helpful for like a quick review because I know a lot of people had questions about that. I'm going to share my screen back to that class 1 agenda. So again, we're still on our class 1 agenda page, right? We had done the attendance quiz. I went through a short PowerPoint about questions that you guys had get done. We did part of this worksheet. So the last thing that we're going to do is part of this case study. So this case study is about hair. I think it's an interesting one. If you guys are curious about why some people have curly hair versus straight hair, you can read through this. We're going to skip part 1 and we're going to skip most of the words for part 2. So the last thing that we're going to work on, and I'll show you where you're going to submit your stuff, is this question right here. So I want you guys to be able to tell me about ionic, covalent, and hydrogen bonds, and Part 3, question 1. So you're doing part 2, question 1. Tell me the difference between ionic, covalent, and hydrogen bonds. And part 3, question 1. What are the building blocks of our macromolecules? And draw and describe a reaction to show how a dipeptide is formed. You don't have to do this second part. I really just want you to tell me what we just talked about. What are the building blocks of our 4 major macromolecules? And this, ionic, covalent, and hydrogen bonds. And so what I would like for you to do is to put into a document, or you can take a picture if you've been handwriting, that's totally fine, what you worked on for this, the language of anatomy worksheet, those 2 sections. Okay, I would like you to put that and those 2 questions, and you're going to submit them as your class 1 assignment. So if you are in, let me make sure I'm in student view here. Give it a second, it's thinking. Okay, so if you are here on your Canvas page and you scroll down, what I would like you, I scrolled too far. What I would like you to do is put them here on your class 1 assignment. So the answers to those 2 sections from the language of anatomy worksheet, and then the 2 questions from the case study, part 2, question 1, and part 3, question 1. So explain the difference between ionic, covalent, and hydrogen bonds, and what are the 4 building blocks of the 4 major macromolecules. Okay, those 2 pieces are going to come together and you're going to submit them here. You can submit multiple pictures if you've been handwriting, or a document. Okay, and so I'm going to let you guys go so that you can work on that last question and submit that last question. And that is what we're going to conclude with for today. Do you guys have any questions about what you're doing? What's due today?
So when everything's done, we just submit that one document to you.
Exactly, exactly.
Okay.
So one document with the language of anatomy, those 2 sections that we just talked about, we just went over, and then those 2 questions in the case study. And again, they don't have to be, you don't have to be perfectly right in your answers. I just want to see that you worked on that. So you've got 7 minutes left for our scheduled class time. The first question, you might have to think about a little bit, but the second question we literally just went over. So that one should be pretty straightforward. Any questions about what you guys are working on, what you have coming up due this weekend, anything like that? Okay, you guys are good to go. Please submit that work once you finish those 2 questions, and I will see you guys next week.
Thank you.
Enjoy your weekend.
Thank you. Have a good weekend.
You too. Stay dry out there. I know it's bad weather. Okay. Morgan, did you have a question?
No, ma'am. Sorry.
No, you're good. Heidi, did you have a question?
No, I didn't.
Okay, I'm gonna close the room then, guys. Enjoy your weekend.
You too.